Question number 31. Consider the following complexes of nickel. So we've been given 4 different complexes. We have NiCO4, we have NiCN4 2 negative, and we have NiCl4 2 negative. So looking at the options, the examiner seems to be interested in the geometry as well as the magnetic nature of these complexes. So let us start with NiCO4, students. So we have nickel tetracarbonyl. So nickel is present in a state of 0 over here. So we have S2D8 configuration for nickel 0. Okay. So carbonyl being a strong field ligand, it is going to cause pairing. So it is going to have D10 configuration. So Ni in NiCO4 is going to have D10 configuration. So obviously the complex has to be sp3 hybridized. And we can see that all the electrons are paired up. So it is going to be diamagnetic. Okay. If you look at the second complex now, NiCN4 2 negative. So in NiCN4 2 negative, we have nickel in a state of +2. So Ni plus 2 has a D8 configuration. And if we talk about the cyanide ions are strong field ligands. So we can call them SFL, which stands for the strong field ligand. So strong field ligand will cause pairing. Okay. So if we look at the d orbitals of nickel, so all of these electrons are going to be paired up. Okay. So one of the d orbital is empty. So the complex is going to have a dsp2 hybridization. And since there are no unpaired electrons, so it is also going to be diamagnetic, as all the electrons are paired. Okay. So in the last complex also, nickel is present in a state of +2. So NiCl4 2 negative. But chloride ions are weak field ligands. So there will be no pairing in this case. Okay. So as there is no pairing, so the electronic arrangement will be in this fashion. So there will be 2 unpaired electrons. So it is going to be paramagnetic. Whereas the hybridization is going to be sp3, as there is no pairing in this case. So d orbital is not available for hybridization. Okay. So we can now look at the options which are given to us, students. So the first option, it says both NiCN4 2 negative and NiCl4 2 negative are paramagnetic. This is incorrect, students. NiCl4 is paramagnetic, but NiCN4 2 negative is not. If you look at the second statement now, both NiCN4 2 negative and NiCO4 2 negative are paramagnetic. Both of these given complexes are diamagnetic. So the second option is also incorrect. If you look at the third statement now, both NiCN4 2 negative and NiCO4 are square planar. So we had seen that NiCN4 2 negative is square planar because of dsp2 hybridization, but NiCO4 has a sp3 hybridization, so it is going to be tetrahedral. Okay, so NiCO4 is not square planar, so it means that the fourth option must be correct. Let us check the option. So it says NiCN4 2 negative is square planar. This is correct, students. And NiCl4 2 negative is tetrahedral. This is also correct, students. So for this question, we have to mark the correct answer is option 4. Let us look at the next question now. Question number 32. Mond's process is used for the purification of metal. During this process, following steps takes place. So the impure metal is heated with CO. We have the formation of volatile compound, and then it is further heated to obtain the pure metal. Okay. So we know that Mond's process is used in the purification of nickel, students. So we have nickel impure. It is heated with CO. It forms a volatile compound, which is the nickel tetracarbonyl. And we have a pure metal again, which is nickel. Okay. So we have to select the incorrect statement for this process. Okay. So the first option, it says that the metal is Ni. So this is correct statement, student. We had seen that the metal is indeed Ni. If you look at the second statement now, Hybridization of volatile compound is DsP2. So the volatile compound form is nickel tetracarbonyl, and we had just seen in the previous question that it takes a sp3 hybridization. So the second statement is incorrect, student. If you look at the third option now, hybridization of volatile compound is sp3, this is correct. If you look at the fourth option now, there is no unpaired electron in central atom of volatile compound. So this is also correct, students. We had just seen that Ni0 has a D10 configuration in this case. So it is diamagnetic with no unpaired electrons. Okay. So for this question, since we have to mark the incorrect statement, so the answer to this question is option 2. Let us look at the next question. Question number 33. In separate experiments, sample of AgNO3 and lead acetate is first treated with thiosulfate. So it is given to us that both form a precipitate, and then the precipitate is heated. Which is correct statement among the following? Students, we have Ag plus and we have Pb2 plus. So both of them are allowed to react with thiosulfate and form a precipitate. So Ag, it forms Ag2S2O3. Okay. And lead, it forms PbS2O3. So both of these are white in color. Okay. So when they are heated, so it decomposes to give us Ag2S, whereas the lead thiosulfate, it decomposes to give us lead sulfide. Okay. So we have lead sulfide and silver sulfide. Both of these are black in color. Okay. So if you look at the options which are given to us, the first option, it says both AgNO3 and lead acetate first form a white precipitate, and on heating the color changes to black for both. So this is the correct statement, students. I don't think there is a need of looking at the other options. So the correct answer to question number 33 is option 1. Let us look at the next question now. Question number 34. An anion X, when heated with zinc in acidic medium, produces a gas Y, which when treated with permanganate ion, its color gets disappeared due to the formation of compound Z. So students, we have zinc in presence of H plus reacting with some anion, let's call it as X. So it forms a gas Y. So Y on reaction with KMnO4, it decolorizes it, forming compound Z. So the Mn must have converted from KMnO4 to Mn2 plus. Okay. So the Z has to be Mn2 plus. Okay. And if we talk about the compound X or the anion X, we have two options, sulfate or sulfite. So we know that sulfite, when it is allowed to get reduced by zinc in presence of acidic medium, it forms H2S gas. So students, the compound X or the anion X has to be sulfite ion, whereas the compound Y has to be H2S, whereas the compound Z, as we had seen before, was Mn plus 2. So students, if you look at the options very carefully, we can clearly see that for this question, we have to mark the correct answer as option 3. Let us look at the next question now. It's question number 35. Which of the following cation forms white precipitate with dilute NaOH, which is soluble in excess of NaOH? Students, if we talk about a hydroxide being soluble in excess NaOH, it has to be an acidic hydroxide or a amphoteric. So basic hydroxides will not be soluble. And if you look at the options, we have Cd plus 2, Fe plus 2, Mg plus 2. These three are basic in nature. The hydroxides will be basic. So only lead plus 2 is amphoteric. So lead plus 2, it will first form PbOH whole twice, which is a white precipitate. And upon addition of excess OH minus, we're going to have the formation of complex PbOH whole 4, 2 negative. Okay. So students, for this question, we have to mark the correct answer as option 4.